All right. So Matt already introduced me. Folks, I'm the general manager in AWS. I lead the EventBridge and Step Function services. Some of you were at the workshops yesterday, so you got to try out some of these services. I've been with AWS for about 10 years now, a little over 10 years. I used to run the services that were before serverless, which was auto-scaling and scaling servers and EC2. So I've been tangentially connected and now actually connected with the serverless world for a while. I flew in from Vancouver, Canada. The EventBridge and Step Functions teams are based out of Vancouver in Canada. And obviously, we're huge, passionate supporters of serverless. We use it ourselves. I'll be sharing some stories about how we have accelerated ourselves. And obviously, once we're done coding and operating the services, we go kayak and canoe in the wonderful ocean next to Vancouver. And it's all sunny. I'm joking. It's super rainy. It's the first day of fall. And I got to Paddington Station yesterday. It reminded me of home, except my body's telling me it's 8 hours earlier, so it's about 2 a.m. I should be going to sleep. So bear with me on this one. We'll try to power through this, and I want to leave you folks energized for the rest of the day as well. I'm really hoping I can manage to do that. So, full pun intended. As we get to talking about the future, we will absolutely talk about the future. And hopefully the AWS employees don't call me out for violating some NDA stuff here, but we will be talking a little bit about what AWS is working on. I wanted to do a bit of a replay. As folks know about replaying and being able to replay events is a big part of an event-driven architecture. I wanted to basically set the stage for we have amazing speakers. We have folks from Lego, other AWS speakers. Julian is going to be speaking after me and actually going into the guts of how we decided to build serverless espresso. I wanted to basically kind of set the stage about what EDA is, some of the history of EDAs, and then actually share AWS's strategy. What have we been up to over the last few years to get to the present? That's where we catch up, and then we'll spend a little bit of time talking about the future as well. That's what I was hoping I would do, is key off the rest of the speakers and make sure everyone here is up to speed. And we're starting with EDA because EDA is the key architecture for serverless. That's why Lambda, which I would argue created the serverless category, is by its very nature an event-driven compute platform. Yes, we've over the years brought many other types of workloads on it, but it's still a bread and butter for us as event-driven architectures. So getting into it, what are event-driven architectures? And before we talk about event-driven architectures, let's find something to compare to. Although, again, I'll be going into this. You don't have to start with synchronous microservices. You can absolutely start with monoliths as well. In fact, one of the most common customer conversations I have when I'm asked to talk about event-driven architectures are with customers who literally are migrating and they're skipping the step from going to my synchronous microservices and migrating their monoliths, sometimes 20, 30-year-old pieces of software, to event-driven because they really want to get the most out of the cloud and most out of serverless with this. So starting with synchronous microservices, the world's kind of simple. You have a user. I'm going to use the example of a canonical e-commerce store or e-commerce app where you have a user. They're trying to purchase something. They've gone through your inventory. They've decided to spend money at your e-commerce store. So we have a back-end service that's going to handle this. It's going to fulfill the order, charge the customer through a payment service, maybe give them loyalty points if you have a loyalty points program as part of your service. All simple, life's good, you're using microservices, everything's great, except when it's not. In a synchronous world, for example, if the payment service is having an issue with the downstream payment or credit card companies and returns an error, now your user who's absolutely made the decision to spend money with you gets an error. Similarly, the user may or may not have loyalty program points, but if the loyalty service is having an issue, because it's not a question of if they'll have an issue, it's a question of when. That's the reality of operating these systems. If it has an issue, guess what? Now, a customer who doesn't even have a loyalty program might actually be waiting 10 seconds or up to 10 seconds. And for folks, this 10 seconds is a long time in our world now. You can watch a whole TikTok video in 10 seconds. People will be checking their internet connections at this point if it was waiting 10 seconds. Another one is coupling between the components, because you're not going to be able to order something or charge a credit card if you actually don't have the inventory for it. So now the fulfillment system and the payment system and the ordering system are all actually coupled. And there's a wonderful XKCD for this. I didn't decide to put it in here, which talks about distributed monoliths, where we've decided to go to microservices, but you can't actually deploy them because they're so heavily coupled together. And you have to kind of orchestrate deployments between them. And then finally, we know our systems are not static. Like what if you add a CRM system, you have a Salesforce system backing your loyalty program, or want to track customer behavior or track customer usage for future, for example, marketing and email campaigns. Now you're adding more and more systems to this ecosystem, and again, more points of failures, more points of latency, and more challenges deploying and operating the system. So, event-driven architectures. And now, event-driven architectures are actually not a new concept. This concept has existed for at least 30 years. There have been products in the market like TIBCO and IBM and Oracle where they had this thing called enterprise service buses. Actually, as a show of hands, are there folks here familiar with enterprise service buses? I see a few hands. So I mean, these things were there, and the reason not everyone raised their hand and these things are not popular is because they basically are failed products. And the reason they failed is even though they gave the promise of loose coupling, they actually ultimately coupled systems even greatly together, and the scaling bottlenecks they created ultimately were the death of those systems. So event-driven architectures is really, at the end of the day, an architectural style of loosely coupled systems talking to each other over events. And look, with any architecture, it's only the right trade-offs. There's no such thing as a magical right architecture. Event-driven architectures have their pain points as well. And as I get into the future and I talk about some of the things that we're cooking up in AWS and maybe even outside of AWS, these are the challenges we have to take, and these are the rough edges of this architectural style that we will actually be tackling. So it's good to actually kind of have these things in mind as we talk about the future. So firstly, it's a mindset. When I talk to customers about event-driven architectures, it's not just about the technology. It's not about which event broker. It's not about using Lambda for your consumers and producers. It's actually about, it starts with organizational design and the style of the software development that you want to do. COVID certainly was a huge boon for us. And even post-COVID, EventBridge, Step Functions, these are the services I own, are seeing tremendous growth because companies have really realized, customers have really realized this asynchronous style of development. It doesn't have to be actually separated or geographically separated teams. You can have geographically separated individuals who own certain components in your company or support certain components of your architecture. Creating that loose coupling within your organization, it's not just in your code, is part and parcel of what we try to do with event-driven architectures. Obviously, Matt already alluded to these things being asynchronous. They're asynchronous and eventually consistent. This is the challenge. So yeah, with the synchronous system, you could have, in the example I was giving a few slides ago, you can actually pinpoint, hopefully, where something is going wrong. The loyalty program microservice is being latent. The payment system is returning errors. In an eventually consistent and asynchronous system, it becomes harder to identify what is actually not working. So that is the trade-off, or one of the biggest trade-offs is asynchronicity and all the challenges that come with asynchronicity. Again, loosely coupled, services don't call each other. And basically at the heart of these architectures is the capability of your code, your systems, your data being able to, or data change events being able to be emitted easily and consumed easily. That's at the heart of the architecture. And so the reason, and I've already alluded to some of these reasons, but where customers are coming to event-driven architectures, I talked a little bit about monoliths, I talked a little bit about synchronous microservices. In many cases, customers, as I said, are looking at really old software, like that they really want to actually get rid of. And I'm hoping some of the folks in the later talks will get deeper into the strangler pattern, which is a very common pattern that's used for event-driven architectures, how you get that speed and agility from where you currently are to something much more modern. But the agility and speed and iterations and iteratability of your architecture is one of the key aspects of event-driven architectures. I'll share some actual anecdotes from customers in a bit too. Resiliency, yes, you lose observability. Yes, it becomes sometimes harder to debug issues. But loosely coupled systems are inherently resilient because they fail independently. And as again in the example I shared earlier, and you're at the mercy of in a strictly constrained or synchronized system, you're at the mercy of your least reliable component. And in the case of the event-driven architecture, because everything is decoupled, you are no longer giving a singular experience to your customers. You're able to give a very, very reliable experience to your customers without having to be at the mercy of, as I said, your most brittle components. And finally, scalability. Like synchronous microsystems, again, are whether they're monolithic or they're based on synchronous microservices, are at the mercy of your least scalable component. This oftentimes is the relational database, but doesn't have to be. With event-driven systems, you can actually split out your domains. You don't have to have this one monolithic giant data table that you have to work against. So just generally, just way, way, way more scalable, orders of magnitude more scalable than synchronous systems. So as I get deeper into event-driven architectures, really there's three fundamental parts. So there's producers. Producers could be your database, which is producing change state events. It could be your own application code. It could be a third-party SaaS application. I was doing a talk a few weeks ago about the proliferation of SaaS apps. And when we started, I joined the organization in 2019. And when we started, some of the stats was that an average organization had about 8 SaaS applications. Now that number is at 50. So certainly in the 3-4 years, the buying off the shelf and actually, speeding up your development and focusing your developers to focus on the real, true special sauce that you're cooking up in your organization has become such a key strategy for so many customers. So producers could be any one of those. And again, your code running in Lambda is probably one of the best ways of producing code. But the best way of consuming those events is actually on Lambda as well. And so on the other half of it are things that are listening to these events. And obviously in a choreographed system, your consumers also then produce events after they've changed something. So there is a dance here. But at the heart of these things is an event broker. And I will get into the event brokering and then event broker technologies and what we're doing specifically in AWS around them. But at the heart of it is the event broker, which is actually facilitating reliable consumption of events from producers and sending them to the consumers reliably with retries and replays, etc. So in AWS, and I'll talk a little bit, now we're getting into a bit of the present. I'm going to start a little bit about AWS's strategy. How did we approach the EDA challenge? And then we'll get into the future of things. Just through a show of hands, how many folks here are familiar with EventBridge? Quite a few. I remember going to reInvent 2019, which is the year where EventBridge was launched, and I had just switched roles. I used to run all the auto-scaling services, and there was a whole host of customers I used to meet every year in Vegas, which is our big conference there. But I would talk to people about EventBridge, and no one had a clue. A room like this would have like 0 hands, so it's wonderful to see the proliferation there. Step functions, again, show of hands. How many folks are familiar with step functions, knows what it does? Again, lots of hands there. SQS and SNS? Pretty much everyone. Lambda? Hopefully everyone? Awesome. Kafka? Quite a few hands there too. Kafka's super popular. It's the open source answer for event brokers as well. Look, at the heart of these technologies, and it looks like most of the folks are super familiar. I just want to make sure I distinguish these things. EventBridge has been our approach to be EDA in a box. If you're starting with event-driven architectures and you want to go somewhere in AWS, you start with EventBridge. EventBridge is already connected with all AWS services, all other capabilities. It's a great starting point, and we've built a whole set of the technologies around it to help you build your architecture so you don't have to build a lot of bespoke systems and operations around it. Step functions, even though it's not choreography, it's the other side of event-driven architectures where you are able to orchestrate the work between these disparate systems. So in the example I gave previously of the payments and fulfillment service, you would actually, if you truly have a transactional behavior between these systems and you want to keep them loosely coupled, that is where you would actually use a workflow with an event broker, where it's essentially a distributed transaction. So using that example, in a workflow, you would be able to trigger the fulfillment activities as well as the payments activities in parallel. If either of those things fail, or there's a concern around inventory or a concern around the credit card transaction going through, you can actually reliably roll back both systems. And that's effectively a distributed transactions. And they're very common in event-driven architectures. SQS obviously is a great way, super scalable way of connecting a producer and consumer, one producer and consumer together. SNS is a great way of connecting one producer to many, many, many consumers at very low latency and high throughput. And Kafka is our, and I should have put Kinesis here as well, but Kafka is our event streaming platform, often used again by lots of customers as their main event broker. Now, with all of these technologies put together, and again, we've done, as I kind of described to you what these technologies are doing, they're doing very bespoke things. They play a very bespoke role within our ecosystem, and really allowing, and no pun intended to the Lego folks, there really are the Lego blocks through which the developers can actually connect and build their event-driven architectures. But we've really aimed them at developers. So they work with our ISE technologies, they work with our observability and metering platform, and they have a whole and growing ecosystem around there. Julian probably will talk a little bit about this as well, but we've had third-party tooling and capabilities that are built and integrated with these things as well, just to make developers' lives a lot easier. And then, again, from a strategic perspective, that's where we've really approached things, is that we've said, look, we will build the Lego blocks, we'll make them as amenable as possible to our developers and customers so they can build their architecture any way they desire. And ultimately, the challenge which I spoke about with ESBs, which no one or hardly anyone was familiar with in this room with, we really wanted to tackle that challenge where these things truly are at cloud scale. They are not going to be, you're never going to run into like scaling limits with these things. Specifically, you're not going to run into organizational scaling limits. So oftentimes when I talk to customers who are talking to me about these monoliths or other technologies that they're using, they're stuck organizationally. They can't get past because that one team that manages this central platform for them is the bottleneck. And so we designed these things from the ground up so that even organizationally, you're not dealing with these bottlenecks. So here's a timeline. I deliberately started at 2015 because 2014 is when we launched Lambda, and I believe that's where the serverless category got created. You can see some key things here where you can see around 2019 there's a whole burst of launches and activities which are really centered around making event-driven architectures a much more amenable reality for many, and much more accessible reality to developers. You don't have to be an absolute expert in asynchronous systems now to build these things. And in an interesting story I often share with customers, like, look, I am an owner of a set of serverless services. I lead the engineering and product teams for them. But I'm also a customer. EventBridge and Step Functions are not huge teams. They're both around 50 people with all the scale that I'll be talking about in a second. They're not huge engineering and product teams. But early on in 2019, I made the call. It was a very difficult call at that time. We had just launched EventBridge. I just shared a story where basically no one knew about it. But I made the call to actually ask the engineers who were experts on building systems on EC2 and servers to actually use serverless technologies to build new capabilities that we add on top of EventBridge. So and Step Functions. All these things you see in red, I've highlighted a whole bunch in Step Functions of EventBridge, and by no means they're comprehensive. I did the math. We launched 6 new services and something like 48 new capabilities over the last 4 years. Specifically because we decided, like, hey, look, we're never going to be a huge team of engineers. We can't let each technology bog down our operations. We have to move fast. And so as we develop and we bring new things in the world, we can't let these things hold our own velocity back because we're going to continue inventing. And the picture tells a wonderful story. I am going to be actually talking about a few things. I'm not going through all of the things in the slide because they're connected to the future. I will be talking a little bit about EventBridge Pipes, which is something we launched late 2022. It's a key part of our strategy, and I wanted to talk a little bit more about that. But this is kind of like the timeline. This is since the launch of Lambda, we really realized we have a huge opportunity for helping developers build event-driven architectures, and we've been building services and capabilities since then. to really accelerate this thing. And then as a result of this thing, we are already at massive scale, like these mind-boggling numbers. If you look at SQS's peak traffic, this is the latest figure from marketing, 86 million messages per second is incredible. I already mentioned to you folks about EventBridge being, if you don't know where to get started, you could start with EventBridge. And the reason for that is EventBridge is the most popular event broker in AWS right now with 1.5 million customers. And the reason for that is EventBridge, for those of you who don't remember, is actually a rebrand of the CloudWatch event service, which was originally built to just receive events from AWS services. So for many of our developers, many of the AWS customers, their first event-driven architecture really was an automation, a Lambda function, for example, that they would trigger in response to an AWS event. Like it could be any change state event, a health event, a CloudTrail event. And customers loved that experience, and we decided to extend that experience then to third-party applications as well as your own applications. So huge scale there. And as I mentioned, step functions as well. With step functions, these are, when I talk about billions are, these are just for external customers. But internally in AWS, the use of workflows and step functions is massive. I mean, I can confidently say that there's no piece of software or infrastructure that we provision, guess what, we're an infrastructure and software cloud, that doesn't use workflows. Like, this is the most reliable way to scale distributed systems, and obviously has huge internal usage as well. And finally, before we get to the future, I wanted to talk about like some real customer anecdotes and what we've seen from customers who are operating and using our ability to scale this way. So iFood is a Brazilian food delivery company. I don't know what, I guess Uber Eats equivalent of Uber Eats. It's the stats I just pulled. These are the two customers that I pulled, which were just handy from our solution architects. I looked up in their Slack channel last night. Like this amazing number, and it's the one that obviously is near to my heart when it comes to developers and finding developer agility and velocity, is they improve the developer velocity by 50%. Now, obviously, there's this other little-known company called Amazon. I have an anecdote from them too. This is Amazon FinTech. So this is Amazon Payments Services. They moved from a synchronous microservice architecture. Amazon arguably is the place which really popularized service-oriented architecture in the late 90s and early 2000s. They themselves re-architected away from synchronous microservices to a event-driven platform, and they're also showing that they've increased their feature velocity by 40%, which is just awesome numbers. That's what we wanted to create in the world, and it's exciting to see customers bring it. Okay, so I think we're done replaying. We're caught up to the head, so let's talk about the future now. And so I'm going to talk about 3 specific areas where I feel we still have a lot to do to make EDAs more powerful and just help developers accelerate even more and get even more done and get even more hyper-focused on the special, unique value that they're trying to create in the world. I'm going to be talking about more integrations, because integrations is at the heart of our strategy. Like, ultimately, with SQS, or especially with EventBridge and step functions, you're calling an API. Well, if I had to really boil down what EventBridge does at the heart of it, is that it matches your event to a set rules, and it triggers an API. Same thing with step functions. It takes an event or it takes a payload, and ultimately you're manipulating that payload, calling another API. So our strategy in AWS is very API focused. So having more integrations and more capabilities around APIs is going to be so key. And finally, this is more like the crystal ball stuff, well, probably 24 months out, it's not even that crystal ball-y, where I want to touch where I think EDAs could go, potentially. I'm not saying they will go that way, but I definitely see signs where we can actually make their applicability and performance improvements to the next level and see what that actually unlocks for us. So firstly, let's talk about the developer experience. I mean, I've already talked a little bit about our prime focus. If I look at our prime mission, it really has been not to actually go low code or no code. That's actually not the point. I love this quote by Antoine Saint-Exupéry about perfection. It really isn't about becoming a no code solution necessarily. It really is about striving to let developers only really write the code that matters and really helping organizations move a lot more faster. Now, a lot of the challenges we saw with serverless, or a lot of the early use cases of serverless that we saw, were around transformations. People were writing these shim lambda functions, which were doing a little bit of transformation, a little bit of massaging, redaction of the data, and then ultimately calling an API. And so that's not great for developer time. It's a pretty heavy lift in many cases for people. At the end of the day, you are writing code that has very little value. So one area where I feel we're going to continue to make progress is, can we offer these transformation capabilities, redaction capabilities outside of Lambda, where effectively in a very user-friendly way you can set these things up so you don't have to write this shim code. You're not spending time writing boilerplate and dealing with boilerplate of integrating your systems together. I already kind of set this with the second point up when I was talking about event-driven architectures. One of the fundamental problems with them, and it's okay, we should call a spade, is around what is happening in my system. I don't know what is happening in my system. So whether it's within Lambda, whether it's within EventBridge, Step Functions, and our other services, we're going to be investing heavily, and this is something you'll probably see in the next few months, not even that far out, in more logging and debugging capabilities. So you're able to really see what's happening in your system. And through the power of other monitoring and logging capabilities in AWS, we're able to bring that to you. You're not trying to put like log lines everywhere in your code yourself to figure out what's happening and why things are not working. And I picked schema validation as a third point, but it's really a class of problems. It's this other class of problems with event-driven architectures, which is around backwards incompatibility or poison pills. What if your system gets an event either through a once in a blue moon or less than a blue moon bit flip that has corrupted the data? What if someone is starting to emit events that are backwards incompatible? Or what if someone's actually trying to maliciously impact your system by sending events which are malformed? Oftentimes, this is an exercise left to the developers today. They have to go figure out how to handle and guard against these things. But I actually think AWS-wide schema validation, whether it's within Lambda, whether it's within Step Functions, EventBridge, or SQS, or SNS, or Kafka, we have a huge opportunity to simplify some of the really, really tough challenges with EDAs by having that schema validation. So I definitely see these things coming up. So this is pipes. Actually, just a show of hands, how many of you have ever heard of EventBridge pipes or have tried EventBridge pipes? Very few hands, and that's just the nature of the beast. When something new is out there and AWS launches so much, it's so hard to figure out. EventBridge pipes, so it will be new for the whole crowd here, and so it's, while it's not the future, it's the present. I still think it really ties into that developer experience. So I talked about having bespoke technologies. We talked about SQS, SNS, Kafka, Lambda, EventBridge, Step Functions to do certain things, but it creates this API footprint. Now, when you come to AWS, it's like, well, which Lego blocks do I pick to put together, and how do I actually learn the nuances of them? So it's the nuance part that we decided to actually take away with EventBridge pipes. So they're called pipes, and they're inspired by the idea of Unix pipes, where you have something on the left, you have a pipe character, and then you have something on the right where you pipe things into. It's very similar to that idea where on the left here, left there, we have a set of AWS services like SQS, SNS, Kafka. These are your main event brokers. DynamoDB streams, so these are change stains events from Dynamo. In the middle, you have the pipe. A pipe is effectively like an EventBridge rule where you can, through configuration, filter events, or only respond to interesting events from the data source. You are now able to enrich them. There's a whole set of services there. And again, when I was talking about easier enrichment and redaction capabilities, I feel what we need to do here in this phase is to make it even easier for developers without having to write a Lambda function or call an API to be able to transform things. And then after that optional enrichment step, you're able to take that event and you can write it to any of the 14 targets or 20 targets that EventBridge supports. Now, again, we're talking about the future. In the future, I actually really believe pipes should need to work with any API and target any other API. So it doesn't have to be a set of services. And we'll talk a little bit more about that when I get to integrations. But going back to the developer experience, getting pipes to be more ubiquitous and the de facto way, whether regardless of the event brokering technology you're using, is going to be a key thing. Again, some of the things we're trying to do here is better logging and visibility support. But this becomes your de facto consumer. You don't think about starting with code first. You think about how do you connect your systems and events together, who needs to know what needs to be enriched. You really are thinking like in an event-driven architecture versus thinking in code first, which I think is going to be really, really powerful. And again, it's not a fight between configuration and code. That's definitely not the case, but I wanted to share this little GIF here of someone building a really, really cool workflow in Workflow Studio in Step Functions. An interesting story, when the team brought this idea to me in 2021 that they wanted to build a visual workflow service, I was completely against it. I actually had to disagree and commit for two reasons. I wasn't sure if developers would actually buy the idea of building a visual or using a visual builder as part of their workflow. And two, and I know it sounds maybe sad or funny depending on how you feel this morning, I didn't believe that AWS had the ability actually to build a great UI. I'm not going to comment on Amazon.co.uk's UI or our own console UI, but what we've done is basically created a new UX language with this thing, and it has been spectacular. We've seen a huge adoption from developers, and I'm happily wrong, and I was happily wrong in this case. The team absolutely did a fantastic job of both developing the UI and thinking through it, and then we've actually seen a trend change, like almost a inflection point for the Step Functions business because of this capability. I'm going to again ask everyone to raise their hands. How many people here are familiar with App Composer? 2 hands? I'm not wearing my glasses, so maybe I'm off. Again, one of the challenges we have is about proliferation. App Composer is a new service we again launched late last year at re:Invent. It's there to visually build infrastructure as code. Today it supports the serverless applications, but really ultimately, again, we're talking about the future. We believe it is going to be a complement to CDK. So you either write code to generate your infrastructure, or you write a visual builder. And App Composer has taken that same UX language from Step Functions and has built that in. And I actually think visual builders are not going away. I actually think right now they're all available in the console. I think that we're very soon going to see these things in your IDE, in your developer's IDE, as standalone appliances. And one of the big advantages when we talk to developers about this is they're amazing at prototyping, they're amazing at learning the technology, firstly. B, it's really a great way of showing your new developers and new teammates and bringing them up to speed on the architecture, because now they can visually see what's happening. And then finally, for your non-technical user or your business users, is a great way of communicating with them and showing them what's going on in the system as well. So I don't think this is going away. In fact, we're just seeing the proliferation of that for infrastructure as code as well. And look, these days it's hard to do a tech talk without talking about LLMs. And this is coming from a genuine place. I have already used some of the public LLMs that are out there to actually build workflows, or build EventBridge rules, or actually get the LLM to produce an event-driven architecture where they're generating all the configuration in EventBridge and Step Functions for me, and even writing some of the Lambda functions. It's incredible. And AWS is not far off as well. We've already announced Bedrock, and there definitely are things we're cooking up on utilizing capabilities like Amazon Bedrock or AWS Bedrock to build more LLMs, specifically around debugging and developing and setting up event-driven architectures. And one of the coolest things for me and what gets me really excited is if you go to an LLM to actually go create these things, it's really ultimately giving you configuration. So really, you really are getting zero tech debt when you get that output from the LLM. And some of the biggest challenges I find that developers have when you get started about these things is they don't know about certain things. We went through the example of EventBridge pipes, where if you can actually get these best practices about which tool to use when, and using an LLM to guide new developers or even experienced developers as they give their requirements to the LLM, it's going to be incredible. I think this is going to be a giant leap forward in the developer experience. Okay, so we talked a bit about the developer experience and the operator experience there, and where I feel we're going in the future. Let's talk about integrations. So just to catch the room up here, EventBridge supports calling a handful of AWS services like Lambda and some of the other event-driven services. And it supports, as I said, matching events and calling an API, a third-party API. A third-party API that either supports OAuth, supports API keys, or supports basic username and password, which is most of your SaaS providers. It also receives events from up to 50 SaaS providers like Salesforce, and then we have some really big ones coming up in the next few months before reInvent as well, like some of the bigger ones that are missing. But we already have 50 SaaS providers that publish events. Step functions, you can call any AWS SDK API without having to write any code or write any SDK code. So it's really, through that visual builder, as I was showing, you can connect any of the 200 plus AWS services we have without writing any code. Both of them can't right now call APIs inside of VPC or on-prem. Or they can't call APIs that have a bespoke or unique authentication scheme. That's where I see changing. I see across the portfolio and through pipes or EventBridge pipes for SNS, SQS, and Kafka as well, the capability, a uniform set of capabilities around being able to call third-party APIs, being able to call any AWS API, being able to call private APIs, that is APIs for within your own microservices, which are behind VPCs, directly through these integration and brokerage technologies. I think this is going to be huge. Again, it removes a whole bunch of boilerplate, removes a whole bunch of error handling and retrial systems that you're going to have to build if you're not using these technologies. So I think it's going to be huge. Having them uniform across the board is so key to our flywheel of helping developers go faster. Standardizing on HTTP. Look, when I talk about API destinations, those third-party APIs that EventBridge is calling, that was our first step. We really are just using open protocols to basically invoke HTTP endpoints. I believe that's what we need to do for sourcing events as well. And so really harmonizing the end-to-end journey over HTTP and open standards. So there, I get it. Lots of folks talk to me about lock-in. There is ultimately the no lock-in. You are just using these technologies to connect the actual business logic and the actual systems in your company and in your organization. That's where the real lock-in logic is. These things are just using open standards to connect. And as I already hinted, all sources are targets. All targets are sources. Like really getting to that point of being able to connect anything with anything through configuration is going to be incredibly powerful. And I see this happening over the next few months from AWS. Last slide for me, I'm going to hand it off to Julian. Julian's going to get into the real guts of serverless espresso. I know many of you came to the workshop yesterday, and some of you don't. And you can actually go try serverless espresso. It's the coffee booth behind us. So certainly after Julian's talk, when you have a bit of a breakout, grab a coffee and see how this thing works. But this is where I'm talking about things that are further out. And I obviously, since we're talking about the future, I thought I'd get my Star Trek reference, and since we're in the UK, I got my memes mixed up a little bit. But so 3 things here. The first one is around and this is where I'm just trying to get everyone to kind of think a little bit and think about what's possible. And then this means different things to different people. But what if your event broker technology could deliver events end-to-end in under 5 milliseconds? EventBridge, for example, has a P90 latency of 80 milliseconds right now. I believe SNS is about 25 milliseconds. But imagine if you could do it under 5 milliseconds. What would we be able to build? What type of architectures or applications, which today we feel like we have to build synchronously or as a monolith? I mean, monoliths ultimately have their place as well. The place being, if you really like, video games are monoliths. I used to be a video game developer for many years. You need that when your code needs to run in a fraction of a millisecond. But what would we be able to create where we basically have our cake and eat it too if we can have that really ultra-low latency of delivering events? One area that I can possibly see is around actually web apps, which is the most common form of application we have, becoming more event-driven. So the funny thing which we don't realize about event-driven architectures, we talk about how they're new or old, or what's new has become old again, as I've been replaying for you folks today. Silently, or maybe not so silently, the most popular web framework in the world right now is React. And React is totally event-driven. For those of you, I don't know how many web developers are here, people who are familiar with React. React is absolutely event-driven today, except when it needs to come and talk to a backend service, where it needs to fetch data from a backend service or write data to a backend service. That's where it's now where you have to talk to a backend engineer, or you have the mythical full stack engineer who can then write the code for the front end and the back end. What if we actually made it so that it's your web apps are event-driven end-to-end, not just in the UI or not just in the back end, but even together you can receive events from the back end all the way into the UI and update things for the user right there, and be able to take user actions and send them back to the back end with ultra-low latency. What would that create for us? What kind of architectures, what kind of speed of development that it creates for us? How does it let us specialize and create new experiences for our customers if you can get that latency? And finally, since we're in Europe, or I'm certainly in Europe, we think about EU and EU partitions a lot. We think about data sovereignty, basically the trends set by Europe. Thank you for the USB-C for the new iPhone. I'm excited to eventually get one, not this year. But it has become the standard. The data sovereignty has become the standard worldwide. And more companies, more and more organizations, more and more countries are saying, hey, I don't want my data to leave my country's boundaries. And so obviously that has large ramifications for AWS and our regional strategy as well. But at the heart of it is really the user. And the user really wants to protect their data. And at the same time, we also have users which are more and more demanding of lower latency. Our attention spans, I was reading, have even decreased even more so in the last 25 years than before. They were already decreasing. So our users are looking for more and more engagement and a better performance. So why do you have to send your events to a region which is further out, or across the ocean potentially, to deliver that experience where you now literally are bumping against the physics of light and the speed of light, and how much data you can transmit back and forth across the ocean to actually deliver the right end user last mile experience. And so we've already seen the hints of this in EventBridge, for example. Last year, I believe, we launched the capability for global event bus, where you can run an active event-driven architecture in multiple regions, or a failover active-passive architecture. Again, works beautifully with serverless. But I actually think a regionless architecture where you're processing events either through a data sovereignty policy or a performance policy through a global accelerator and CloudFront is going to be the next thing for us and for event-driven architectures as well. I believe this is my last slide. Hopefully this gets everyone jazzed up and excited about the rest of the speakers. I know we have wonderful content and very technical and dive deep content from our next presenters. I just wanted to tee everything up. Thank you so much and enjoy the rest of the day.